All right, quick review question from yesterday. We have square roots in here, and yesterday we talked about the two issues with domain restrictions. Under a square root, we can't have negatives and we can't have zeros in our denominator. So we have to be concerned about these two. The first question is saying to add the two functions together. We can show that they are being added together, but we can't physically add them. All right, they don't match. So there's nothing to simplify here. You're just showing that the two functions are being added together. For our domain, we have two square root pieces that we have to be concerned about. This piece here, x plus 3 has to be non-negative, right? 0 or something positive. It cannot be a negative number, which means x has to be greater than or equal to -3, okay? The other one, x minus 2, also can't be negative. So we're looking at 0 or higher, which means x has to be greater than or equal to +2. When you have two domains like that, where it's a whole interval of numbers that we're looking at, think of your number line. Okay, the first one said x had to be greater than or equal to -3. So from here on up, the second one said x has to be greater than or equal to 2. So from here on up. We need a domain that's going to work in both of those. So we're looking for where do they overlap? What numbers work in both? And that would be this section right in here. Yes? If I pick numbers in here, when I dump them in, let's say we pick a 0. Dumping a 0 in, is it going to work here? No. So my restriction for my domain has to be the most restrictive one. Okay? I have to eliminate any that don't work in all of it. So final domain is from 2 on up. Okay? Okay. We ready to move on? So our topics today, we are going to do compositions of functions. Yesterday you did combinations. You added, subtracted, multiplied, and divided. You combined two functions. Okay? Now we are doing what's called a composition of functions. You would have learned this a little bit last year. Okay? We're going to go through an example because we are going to be composing functions and we are actually going to be doing the reverse. We're going to be decomposing it. I'm going to give you the composition and you're going to work back to figure out what the functions were. Okay? We also have to concern ourselves with the domains, which is why we spent a lot of time yesterday looking at domains. So, what a function does okay? If I give you the function f of x equals x plus 5, it's saying this function is going to take some numbers and just add 5 to them. Yes, that's all it's going to do. It's going to take a number and whatever number you dump in, it's going to add 5 to it. Say we have a second function that's going to take our number and square it. Okay? Now whatever I dump into g, it's going to get squared. I have two separate functions. When we compose them, we are saying we're putting one function into another. Okay? So let's say we are going to do two function boxes. All right? This one will be our function that's adding 5. Okay? This one will be the function that's squaring things. Okay? So when I do a composition, I'm saying I'm going to dump something into this function box. We'll just say we're going to dump in an x. The function is going to add 5 to it. Okay? So I'm dumping that x in. My function is going to add 5 to it. What it's going to spit out is an x plus 5. Okay? Then that function is going to get dumped in to that one. That function box is taking my value that I dumped in, and it's going to square it. What's it going to spit out? What do we get when we take x plus 5 and square it? X squared plus 10x plus 25, right? X plus 5 times x plus 5. FOIL it out. So when we do a composition, we're taking one function, it spit this out, we're dumping it into a second function, and it's going to spit out something else. Okay? The notation that you're going to see for compositions, there's two forms. I personally like this version better because I think it's easier to see which function is being dumped into which one. But they are equivalent. So some books use this notation. You need to understand both ways. It is read f of g. Okay? So we're taking g of x, and then we're taking f of that value. So this g of x function is getting dumped into the f function. Okay? The other direction, this one says we're going to take this f of x function. We're going to have the function box did something, right? And we're dumping that into our g function. You will get different answers depending on which order you dump them in. So you do have to pay attention to what they're asking you to do. Okay? The domain. You have to think just a little bit harder about domain than you did yesterday. Because yesterday we said any domain restrictions from the beginning follow you all the way through. This one is a little different. This one says if there's any domain restrictions on the inside function, the one that you're dumping in, you have to consider those, and then you have to consider any with your final result. Okay? The reason behind that is I can't dump a function in to another function if it doesn't exist. So if there's x values that don't work, I can't use those when I dump it into my second function. All right. So we are taking f of g. So we're taking this g function, which in this case is x squared minus 2x plus 6, and it says we want to dump it into our f function. So how we write this, the very first thing you see is f. We're going to start with our f function, but we are going to leave a hole wherever there was an x, because our second step is now to dump something in there. Okay? We're composing these functions. So now it says take this quadratic trinomial, x squared minus 2x plus 6, and we're going to dump it inside here. Okay? Now, we do want to clean that one up, and we'll come back to that in just a second. I want you to compare the second composition here. Now I've reversed the order. Now I'm saying take g of f of x. Okay? So now that says start with the g function. This g function says something is getting squared minus 2 times that same thing plus a 6. Okay? That function box is going to do that step. Square it, times it by 2 and subtract, and add 6. It's going to do all those pieces. What it's going to do them to is f of x. So my x is getting replaced by a 3x minus 4. Okay? Do you see the difference between the two orders? We're going to get different answers out, so it is important that you pay attention to that order. All right, let's go back and do some cleanup. This first function, we are taking 3 times x squared minus 2x plus 6. If I distribute that, I end up with 3x squared minus 6x plus 18. And then there's a minus 4 on the outside. Okay, combining like terms, we can say that our composition, f of g, is 3x squared minus 6x plus 14. Okay. On the other side, we have to square 3x minus 4. So picture foiling that out. What are we going to get? Nine x squared minus 24x plus 16. Okay. Then distributing our negative 2, we've got negative 6x plus 8, and then a plus 6 on the end. All right. We need to combine like terms. We end up with g of f being 9x squared minus 30x plus 30. Questions about those? Okay, now let's look at our domains. For our first one here, f of g, we look at any domain restrictions on the function that we were dumping in. So are there any restrictions right here on x squared minus 2x plus 6? Do we have square roots or denominators? No. So I could use all real numbers. When I look at my final answer, can I still use all real numbers? Okay, so that's my domain. For our second one, g of f, any restrictions on the 3x minus 4, the function I'm dumping in? Do we have any domain restrictions on that? No. Do we have any domain restrictions on our final answer? Okay. We have composed f of x with g of x and g of x with f of x. Our next two questions say do a composition, but instead of there being an x, we have a number. They're giving us a number to use. So think of the function box that we were talking about earlier. Instead of starting out by dumping a number in, or the x in, we would be dumping a number in. Okay? Rather than dumping a 1 into function g and then taking that answer and dumping it into function f, we've already done the composition. We've already figured out that the composition of f with g is 3x squared minus 6x plus 14. So now we can just dump that 1 into that version. Okay? So we are going to take our x's out and replace them with 1. We end up with 3 minus 6 plus 14, which gets us what? Okay. All right, for our second one, it says do your composition g of f, which we did, and now put a negative 3 in. So we are just dumping a negative 3 into this answer. All right, so what is negative 3 squared? 9. 9 times 9? 81. What's negative 30 times negative 3? 90? Okay, plus another 30? 81 plus 90 plus 30? Okay. Questions about that? All right. I'm going to try a couple more of those. Do we have any domain restrictions on f or g? Yes. What's the domain restriction on F? Okay. And on G? Okay. We're only going to do one composition for these two functions. We're doing f of g. That means we're going to start with our function f, and inside we are going to dump our function g. So I'm going to write down function f, which is 2 divided by something minus 1. I always start with the first function that I see. Okay, I saw an f first. So I rewrote function f and just put a hole where the x was. Now I'm going to dump function g into that. So when I look at my domain, I have to look at restrictions on the function that I was dumping in. So on that little red piece, 3 divided by x, what was my domain restriction? So right away I know that x can't be 0. Okay? Now I have to clean this up and see if there are any other restrictions. How do we clean up 2 divided by 3 over x minus 1? We did some work with this earlier. We wanted to get rid of denominators, right, to simplify our complex fractions. So to get rid of this x in the denominator, I'm going to multiply by an x. But whatever I do to the bottom half of this fraction, I have to do to the top half. What do we end up with? 2x for our numerator. Okay. What do we get in the denominator? Nope. Distribute it in. X times 3 divided by x is just a 3. X times the negative 1 is a negative x. Okay? Be careful when you clean that up. You are not just multiplying the 3 over x by x, you're multiplying the whole thing. Yes? What new domain restriction jumps out at you? What can x not equal? It can't equal 3. So we have two issues. X can't be 0 and it can't be a 3. So my domain, starting at negative infinity, I have to go up to 0, jump over it, go up to 3, jump over that one, and then continue on. Okay? Talk at your tables. What domain restrictions do you see? All right, what are you saying for this first one? Can't be negative 4 and it can't be 0. Okay. F of g again. F of g says start with function f. So I'm starting with function f, and inside I'm going to dump what? I'm going to dump in that 1 over x. I'm going to dump in my second function here. Okay, now, what are the restrictions that we have on the function we just dumped in, that inside function? Can't be 0. Okay, x cannot equal 0. Cleaning this up, we're going to multiply by x again. The numerator is going to become 5x. Denominator is going to become what? Good. 1 plus 4x if we distribute that x in. Okay? Now, our denominator can't be 0. What makes 1 plus 4x equal to 0? We don't want that. So subtracting the 1 over and dividing. X can't be negative 1/4. Okay? So when I write my domain out, I have to jump over 0 and I have to jump over negative 1/4. So negative infinity up to negative 1/4. Negative 1/4 up to 0. And then 0 on up. What did I do with the negative? Okay, good question. Remember I said for compositions, the only two things you have to worry about are restrictions on the function you're dumping in and restrictions on the final answer function. So this f of x was no longer really f of x because we dumped something into it. Does that make sense? So you only are worried about the one that you're dumping in and then your final composition. Okay? All right, this one says f of g again. So we're going to start with function f. We're going to dump in g. Function f is simply a square rooting function. Okay? Whatever we dump in it, it's going to square root it. What piece are we dumping in? The x minus 3. Okay? There's nothing we have to do to clean that up. That's as far as we can go. Were there any restrictions on the function I dumped in? On this function, x minus 3. No restrictions on the domain. When I dump it in, have I created any restrictions? Yes. Because now I've dumped it inside a square root symbol, and we said because of that, it can't be negative. So we have to worry about x minus 3 being negative. The only numbers that will work are the ones that are 0 or positive, which means x has to be greater than or equal to 3. In our interval notation, that would look like that. Okay? We're going to look real quickly at the reverse. What if we did g of f? Now it says start with the g function. Okay? Our g function is something minus 3. And we're going to dump in what? The square root of x. So I'm going to dump in a square root of x. Are there any restrictions on what I just dumped in, on the square root of x? It can't be negative. So my domain restriction, I know that x has to be 0 or higher. Okay. To clean this up, I'm going to take away the parentheses, but there's really nothing I can do to combine those. Have I created any different restrictions? The only thing inside the square root is an x, right? That's the only thing I have to worry about being negative. So I've already got that listed, right? X has to be non-negative. So my domain for this one would be everything from 0 on up. Okay? Do you see the difference between them? Here, in the first one, we were worried about restrictions on this one because that's what I was dumping in. Here, I'm looking at restrictions on this one because that's what's getting dumped in. Okay? And then any final restrictions on our answer. All right. We are going to do the reverse. So we need to start with a composed function, and we want to decompose it. We want to figure out the two functions. There are several correct answers to these. Okay, there's different ways you can decompose them. So you might see something that your partner doesn't see. Doesn't mean it's wrong. When you look at them, what I want you to think about is, can you see a function that is kind of the outer form of it? And can you see something that was being dumped in? Okay? So for our first one, it says they have composed f with g, and it ended up being the square root of x squared minus 3. One way I could look at that is to say I'm going to define function f, my outer function, to simply be a square root of something. Okay? So I'm going to just square root something. What is it that I square rooted? Yeah, x squared minus 3. Whoops. Okay? X squared minus 3. That's one way I could do that. What if instead I define my original function as this? The square root of x minus 3. Now, what is getting dumped in place of that x? Just the x squared. That would be my second function, the one that's getting dumped in. Can you see how both of those would compose to be what we were given? Either of those answers is fine. Just depends on how you look at it. Okay? All right, question 6. Talk at your tables. Do you see an outer function and something that's dumped in? I'm going to pause the recording. I want you guys to try this one. So it is important when you label these that you identify which is the function f and which is function g, because it matters which order you're composing them in. So what is the outside function? What's the kind of basic format that we've been using? Something is getting squared, then 5 times that same thing, and then we're adding a 2. And the piece that was being dumped in is the x minus 3. Does that make sense? Okay. All right, so your assignment is listed here. There is room in my elk time session if you guys need a place to work.